present value of an annuity. In previous modules, we've looked at how to calculate the present or future value of a single cash flow by calculating its value at a different point in time. And we've looked at how to compare or combine multiple cash flows by calculating their present or future value at the same point in time. In the previous module, this module and the next module, we will use those same principles, but we will use some shortcuts which can sometimes avoid having to perform a large number of calculations when there are many cash flows. As in the last module, even though these shortcuts give us the most value with a large number of cash flows, we will use just a few in our examples. As we have seen in a previous module, in principle, we can calculate the present value of any series of cash flows by treating each of them as a single cash flow. This formula shows in general terms how to calculate the present value of n cash flows, assuming that they are to be discounted at the same interest rate, R. The shortcuts that we are looking at in the previous module, this module and the next module are all based on the assumption that the interest rate R and the cash flow C stay constant. The exception to that rule in the previous module was the case of a growing perpetuity. If we have the same cash flow in every period for a finite period of time, in this case $10, the name we give to that series of cash flows is an annuity. We could calculate the present value of these four cash flows by using the techniques we were introduced to earlier, treating each cash flow separately. Before we look at a shortcut formula for the present value of an annuity, it is important to emphasize again that the basic formulas that we use assume that each cash flow occurs at the end of each period. When that occurs, we call it an ordinary annuity. In this case, we have a 4-period ordinary annuity, with $10 cash flows occurring at the end of each of 4 periods. This is the formula for the present value of an ordinary annuity, where C is the constant cash flow, with the first cash flow occurring at the end of the first period, R is the interest rate per period, and N is the number of periods. Let's do an example of this. You have just won a so-called $30 million lottery. You can choose to receive $1 million per year for the next 30 years, with the first payment in 1 year's time, or you can choose to receive $12 million up front. You can invest your money at 8% per annum. Which do you prefer? The only way to make this choice is to calculate the present value of the 30 payments and then compare that to the $12 million cash up front. Here again is the formula. C is $1 million, R is 8% or 0.08, and N is 30. What is the present value of the 30 payments? The answer is a little over $11 million. So clearly a payment of $12 million up front is preferable to $31 million payments over 30 years. In the last part of this module, we will now consider what happens if payments do not occur at the end of each period of the annuity. In this diagram, we again have a 4-period annuity consisting of 4 payments of $10, but now the payments occur at the beginning of each period. We call this kind of annuity an annuity due. The way we are going to solve this sort of problem is by splitting up the stream of cash flows into 2 components. The first component is the first cash flow at time period 0, and the second component consists of the remaining cash flows. We already know how to calculate the present value of the second component. In this case, it is just a 3-period ordinary annuity. We also know that the value of this 3-period ordinary annuity is as at the beginning of the entire annuity period, 1 period before the first cash flow. Since the first cash flow of the 4-period annuity due is also at time period 0, we can safely add these two amounts together to get the total present value of the entire 4-period annuity due. Therefore, this is the formula for the present value of an annuity due, where the variables take on the same values as before. C is the constant cash flow, R is the interest rate per period, and N is the total number of payments. The present value is equal to the present value of an ordinary annuity with N minus 1 payments, and then we add to that an extra cash flow, representing the first payment at time 0. Let's do one more example. You have just won another $30 million lottery, similar to the one from the previous example. You can choose to receive $1 million per year for the next 30 years, with the first cash payment today or $12 million up front. Your interest rate is still 8% per annum. Which do you prefer? Here is the formula again. C is $1 million, R is 8% or 0.08, and the total number of payments is still 30. In this case, we find that the present value of the annuity due is a little over $12 million, and therefore this annuity is preferable to $12 million up front.